to translate my presentation now, so I hope there is nothing in Czech now. What I want to tell you today is about API design and features the good API should have. Before I start, I will tell something about me. I'm a founder of accounting system FlexiBee. FlexiBee is a Czech accounting software with API, and today this API is used by hundreds of developers, and it's used by many companies like Liftago or In-Time Spedition and so on. It's thousands of companies. I sold this company, and I founded a new company called that is focused on integration for developers, because I will talk about it later. I also create video podcasts for developers called Cafe Mlýnek. You can look on some of our videos. They are in Czech, so only for Czech. Okay. What I want to tell you today, and this is the main thing, is API is not only for developers. What I'm talking today about is not. There are three types of API. The first is internal API between front-end and back-end, or internal system, or something like that. That's the first type of API. The second is internal API for your company that is used by different departments or by multiple departments. And today we are going to talk about the third type, and that's API for public, for developers, for many developers outside of your company. And this is what we are today talking about. So API is not only for developers. As I said, I created FlexiBee accounting system, and we added the API support because in the past, one of the reasons I founded FlexiBee was that I was creating an information system for executors. I don't know how to translate it. Bastard. No, bastard. And the thing is that we have to create a connection to the banking, to download statement, to upload orders for payment. We have to generate invoices, VAT information, and so on. And I thought there must be some accounting software that I can connect, and it will do all these things for me. And there wasn't any. So I created FlexiBee, and today you can use it in this way. The API is complete. It has a lot of features, and a lot of developers say, I didn't know that API can do this. And I'm going to tell you today about the features of the API that should be there. So, first question, what is API? REST API or something like that. I know it's their programming interface, but what is important is that the API is finished and is documented. So you don't have to ask somebody to make modifications for the API. This was one of the things in the past that when we created the API, they said, well, everybody's API. Okay, show me that. Okay, what does the API have to do? Get invoice? Yeah, okay, I will create what are the columns names? And that this is not API. API has to be finished and documented. That's the important thing. And it has to be developer friendly. It has to be easy to use for developer. That's very important because developers are shy. Are you shy? I am. And I don't want to register any form. My friend, he wanted to try an API, and in the Friday his family went somewhere outside, so he thought, I will spend weekend using this API. So he got there, and there was form. So he filled it, and got, okay, we will contact you next working day. Okay, it was over. API has to be accessible. So we will be talking about a few things. API has to be easy to start. There must be examples of how to start. For example, in the accounting software, there should be example how to create simple invoice from the start. So you have to make a request like this, usually in SQL or Swagger or some easy tool to connect to it. There has to be tutorials that show something more complex, like creating invoices, but more information, not only the basic request. And of course, there should be reference documentation like Swagger or like API. But the important thing, these two are more important. Usually developer thinks, okay, reference documentation is everything you need. But that's not true, because the developers usually don't know your domain. They don't know how the invoice should look, what is VAT, what is tax date, or something like that. They don't know about it, and they need to know the tutorials that will show them how to make it. So, for example, we created tutorials how to connect accounting software to eShop, because they don't know what everything they can do. So, it has to be developer friendly, and that's not all. There has to be developer license. That has to be for free. No developer is going to pay you for testing your software. It's not about money. We developers just don't pay because we are, I don't know, too poor. And there has to be demo installation for global examples. For example, in FlexiBee, there is a global installation called demo.flexibee.eu, where you can see the application. In this case, it doesn't require password. You can just go there and it shows you the application, and it's shared for everybody. I have one funny moment. Some time ago, I was called by some company, and they told me, on this demo FlexiBee EU, there is unpaid invoices by our companies. And I said, okay, that's demo. We don't like that. Remove it. What? So we removed it, but yeah, they don't like anywhere anything about them not paying. So in this case, this presentation is usually the beginning is for not developers. So maybe it will be you will know already that. But the thing about FlexiBee is that we always wanted to be easy to start. So when we presented the API, we showed users, okay, go to the invoice, and there is an URL, and change the suffix at .xml or .json, and you will get readable version of what you are seeing. That was the API. The API was with documentation. For example, if you have lift, it's not here, but on this example, but there is on every line, on the first row, there is documentation. What does this line means? What is the value it can contain, and the format, and so on, and the explanation. Because it has to be easy for the developer to read it, to start it, and you have to show him everything under this notes. So this is example how we were showing the API. So API has to be open and documented. It must be complete, and it has to. There is a difference between export and the API. It's for developers easy to understand that, but there is a difference. And there is also a difference between REST and RPC. And it's hard to explain because do you know what is the representational state transfer, REST? Yeah, okay. And the question, is it okay to, in an invoice, you can cancel an invoice. Is it okay, it's better to have a property called cancelled true false or an operation called cancel? What is the right way? Yeah, that's the REST way. Yeah. I'm glad you are telling that because I was told many times that it's not the right way. There is also one thing that we called, I don't know if it's in English, idempotention. Yeah, is it idempotention? Yeah. The thing is that an invoice is a document, and it always was a document for 1,000 years. And if there is an invoice and you receive it, and they say, this is invoice number 10 from this company, and you get it. Okay, I get it. And then you receive it again. You should update it because you are receiving this document again. And it's document, so it shouldn't be that you say, no, I don't want it, I already installed, because it's update. I will call about this paradigm later, when we are talking about transactions. So, this is an example about difference between REST and RPC. In REST, you put everything in one request. In RPC, you create invoice, add items, and save. And usually there are multiple calls. That's the difference between RPC and REST, and it's usually change. If you have questions, ask them, because my English is not perfect, so I would like to explain something. What are the limits of REST? Usually today, the external API in most cases is REST. It's not GraphQL. There is no reason why it shouldn't be GraphQL, but it's not still GraphQL. So, what are the limits? Typically, is the problem with correlated requests. In this case, I want latest posts, for example, 10 last, and I want likes for the first, second, my friends, and messages. Problem is that this is many requests. I can call this and this at one time, but these are correlated, so I have to wait for this, and then I can read the requests. Usually, this is handled by something like this. Includes post likes. This is the configuration how you tell what everything you want. This is the way how we implemented it also in FlexiBee, because FlexiBee has REST. It's 10 years, so there wasn't any GraphQL at the time. And this helps to improve about overfetching. That's one of the great features of GraphQL, because in a GraphQL you say you define what everything you want to get, and you will not get anything more. And that's a good thing, because, for example, in FlexiBee, in the REST, we added some features that were there, but later we discovered it and changed the model, and it was in another table. And from that time, we have to read related data from another table for every request. And we didn't want to make it by default to not read it, because it's breaking change, and we don't like breaking changes. So we added to the documentation about speed to use some argument that will disable this reading. But it's bad that you have to tell everybody to improve speed, do this, because it should be fast by default. So it's not that good. So this is the way how GraphQL does it. You just define everything you want and you will get it. In my opinion, GraphQL fulfills representational state transfer. So it's hard to say which one is better. GraphQL, from my experience, is the primary, and today I think the only option for internal API between front-end and back-end. Don't use anything else. GraphQL is the best, and there is best tooling for that, because it's perfect. REST has better support for external developers. There is API, there is Swagger with the auto-documentation generation, but nothing like that is for GraphQL. External API very often is and should be different between the internal and external API. Now there is difference, and you can change your internal API as often as you want, but don't change the external, never. I had a discussion with one company that is very large, billions of crowds, and they wanted to change API, and I was telling them that, if you change something in your API, you can spend 1 week on that, but for your support, it's going to be weeks, multiple times, and for your customers, it will be 10 times costs than you have internally. So, together. So, if you change anything in the API, be very careful about it. And, for example, I'm not fan of, V1 API, V2 API, because almost never you change everything in your API. You just change something. So, instead of V1 something, I prefer v1 something 2. Don't change the complete API, just one endpoint. In FlexiBee, we had some, for example, on, I don't know if I translate it correctly, I would say it in Czech, odpočet zálohy, it should be advance payment.
Deduction?
No, I'm not sure. Deduction. But in advance payment, and you have invoice, it should be related to the advance payment. And we had 3 APIs before we made it correctly. So there were 3 APIs, and each one of them had explanation why it exists and how it works. So, API. So, documentation. Documentation has to be updated. It's very often that the documentation is too obsolete. When you write something, be specific. For example, what is it end date? It's planned date, it's real date, it's estimated date, it's real date, what is it? So every time explain what the field means and also write the measure unit, because if it's count, euros, grams, because very often there is missing the measurement. And always provide an example value, because it tells a lot if it in person is 100 or 1, because you are not using person but number. And I like API, Swagger, I already told that, because there is a lot of documentation in that. In Dativary, we take API, and today it's hundreds of APIs, and we map it to our internal systems. So we have to understand what is, in the case of an invoice, what type of invoice it is. If it's pro forma, advance, if it's cash invoice or bank invoice, paid by invoice, we have to paid by one bank. We have to understand it and know what it means. And my colleague who is doing the mapping, he doesn't like Swagger, because developers usually think that they write only field names that it's complete, like, end date. This means end date. Okay. So be very specific and explain and why it's necessary. Okay, now we will go deeper. I think one of the most important things, there is part of the API that's called authorization. And it's important to have the authorization to be easy. And today I see 2 ways of authorization, and both are valid. One is OAuth. OAuth is like, when you are redirected, for example, to Facebook, and it asks, do you want to provide information to developer A and provide this information? Yes, no. That's OAuth. But very often there is also a requirement for API token. This is usually in case of the company software or enterprise software. For example, you are creating connection to the bank, and when you connect it, you ask customer, I need access to your bank. And in case of OAuth, he has to provide you the authorization tokens, or you have to provide him access to your application so he can accept the authorization in OAuth. And in this case, it's much better to just ask customer for the API token. There are various ways of OAuth that also supports tokens, but I think it's good to either use both of the authorizations or choose the one that is appropriate for you. If the authorization is done by machine, it's usually, the connection is done by the machine, it's usually better to use the API token. If it's done by the customer, it's better to use the OAuth, because you redirect the user and he will be asked if he allows the access. So this is the 2 authorizations we want, and if you are using something else, change it. Because it's proprietary and not supported, and so on. So for example, if I was wrong, OAuth 2, don't use OAuth 1. It's obsolete now. It's more secure, but harder to implement. because there are many implementations and they are not compatible usually. Be consistent, I said this already. All of the parts of your API should behave the same way. For example, error pages should be in the same format, like all the error pages should be same. For example, if you have API that returns error in JSON, and there is a CDN, and when your backend stops work, you should provide the information in the same format. Because usually the format is different. And when we connect the application, we want to show the customer the real explanation why it doesn't work. And it's not good if we have to show him the HTML provided by our CDN provider. Also, the system should be consistent in all parts of your application. For example, in FlexiBee, there is an inconsistency. When you are asking for the company, FlexiBee can make accounting for multiple organizations. If you ask for a list of organizations, the API is slightly different than if you ask for data of the application, of one of the organization. Because in this, you are in the context of the organization, and that's why it's different. What also we usually see is that the enumerations, their enumerations have different API than the rest. Because, for example, you have enumeration that will always have 10 items. So there is no need for paging, but it should be there also, because it should be same and it should be consistent across all your applications. And usually the errors, or what can be often seen is when you are returning JSON and you are returning one item, sometimes is just the hash. If you are returning multiple values, it's arrayed. But it depends on the number of items inside. That's not good. So today, for example, we implemented in the mapping of the model we have, we are today making difference between array and one value. Because in this world, it's so inconsistent that we have to ignore the difference. Okay, be consistent. Yeah, this is example. If you have currencies and there is one, it should return array 2, not only one item. This is very often by some frameworks that, for example, transform sometimes to XML and sometimes to JSON, because XML doesn't have difference like this. There is only a node. So, can we go further? Okay, latency. One of the big mistakes we made in FlexiBee is that we supported batch operations and long-running operations. For example, few of our customers wanted to export their whole accounting to the PDF, except that they have 100,000 invoices. So the server had not enough memory to create such PDF. So every request should be limited what it does. I don't like today, if you want to, the thing is that you can implement some rate limiting or something like that, but if you have requests that can take 10 minutes, it's useless, because you can run 3 requests per minute and still eat all your servers. So, how to make it? Simple request should take less than 100 milliseconds. So if it returns no data or almost no data, it should be that fast. And split all the requests in small chunks. So it means like limit should be 100 maximum or 1000 maximum. And support rate limiting. Rate limiting is standard that says how quickly the system can call you. For example, in FlexiBee, we had many creative developers and they tested their integration on 10 items in a catalog and 10 customers and 10 invoices. And that was quick. But when they moved to production, they were downloading the data still together. You know, for example, they download the data every minute, but it took 3 minutes. So they were able to create millions of requests per day, every day, And the problem was that the developers created it, deployed it, and we told the customer, you are making too much requests. And they say, I told the customer, the developer, and then he said that's not possible. Okay? And so we changed the strategy and we told them, you are using more requests, in 2 days we will shut your API. And that was the only way how we could make them change something and to realize them that it was the developer's fault. But today it's better to use the API limit because it will slow this customer automatically. There is, for example, implementation in Node.js. That's very easy. One of the questions is, this is usually limit for like 10 minutes or something like that. If you want to make limits in seconds, for example, some users can make thousands of requests per second. It's not good to use this rate limit. It's better to use slowing. Like in Node.js, it means that there is a module that you can use, and it will not return error. It will make the request response slower. Like, every request will get 10 milliseconds penalty. So if you make, it will be reset in 3 seconds. So if you make too much requests per second, you will get answer after 3 seconds. Usually the developer is making cycle. He downloads data, then he downloads another data. And if it takes more time, like 3 seconds, it will download slower. And if he consumes his rate limit in 5 minutes, you will return this. But if your platform supports it, if you are using Node.js, it's easy to implement. If you are using something else, you have to depend on the platform, and they usually support only the rate limit. And that means that they can they can create too many requests in 1 second. So rate limiting is the only solution, and if you are not using it, start, because it will make problems on the performance. Because the problem is that you can auto-scale easily with Lambda or something like that, but you can't scale the database. It's slow, it takes minutes or tens of minutes to upgrade performance of the database. We are using DynamoDB, for example, and that's how it takes minutes to upgrade the performance. Okay?
My experience is that APIs don't provide sandbox, so the developers have no expectation or no understanding how the API will behave in production with real data, with millions of orders or something. So it's hard to develop the application without this kind of performance testing. So please provide sandbox.
In case of FlexiBee, we didn't support sandbox, or the demo can be sandbox, but we allowed customers to clone their database, and it had its own performance, so they can test it on the test database cloned from the production. Okay, let's go to the paging. This is very important because you can't download all the data in once. It works in the beginning, but when you start to get hundreds of megabytes or gigabytes response, it gets very slow. So we usually support paging. In case of using SQL database, you can support something like that. If you are using NoSQL databases, usually start with something like that. This has the advantage that, if a customer looks on the first page, then he clicks, okay, I want to see the next page. In the first version, he can still see the same data because, we created a new page of the data, and he's moving to the next page that contains the same, because now it's second page. In this case, he will just see older page and or newer page. So, support paging. It's very important, and supported on all endpoints, even the enums with 10 values. Paging. CRUD. Usually, we like that, for example, in invoice, you get list of invoices. You can get one invoice. In our case, we like to have endpoint containing the related data. This is only possible if you have in SQL, under the hood, Because if it's a document like SQL, usually you can't list invoice items. This is usually good in the cases we have to synchronize the complete database. It allows us to effectively download the data. So provide CRUD operations for reading, changing, or for reading list, changing, reading one item, changing, and also for the sub collections to be like it. Yeah, output modification, I already told. Problem of the rest is that you get all the information, and very often you get information you don't need. So in FlexiBee we supported some, in FlexiBee it was called columns, I think. And the customer provides the values he wants. This is good for lowering the number of data that are going over the network, and usually it takes less performance, less zátěž. It takes less on the server. Yeah. We also use includes. This provides that you can read the items. The problem is in the world today. The main problem of the networking is the latency. It's limited by the speed of light, and it will not going to be faster. So we can't make a lot of requests. So we want to make them less, containing more information we need. So in this case, you can read invoice, but you can also specify that you want to invoice these items. In GraphQL it's easy, in the rest you have to provide it. It eliminates the n+1 problem. When you read 10 invoices, and then you have to read items for every invoice. What I already told you. Filters. Your API should support filters. If you have SQL, support filtering on all items, or at least on something that's important. Usually, we need something like, I want invoices for customer ID 127. That's one way. Or I can provide multiple values, so I will get invoices for 2 customers. Or I can provide some operator like, I want to sum to be equal to 1000. But I can say greater than or something like that. There are multiple ways how to write this down. For example, this is the case of the FlexiBee. This is querying language. Because you have to specify, I want all the customers' data that are greater than something. In this case, we created a simple translation library that changed this to the SQL query. It was easy. It was done in one day, and it provided a lot of things. There are many ways how it can be handled. This is the FlexiBee way. Some is this. I like this one because it's readable. Because of here the browser puts its %20, but here is only the tilde, so it's easy to read. This is the way of eDoklad. eDoklad is doing this check counting software. That is not good. It's invoicing software because it doesn't have accounting. So querying, this is very important if you want to be used by the customers more, because they will ask the information they only need. Yeah, GraphQL filters, blah blah blah. Ordering. This is very important too, because I want to sort the data, and if your backend provides it, we can sort it by many ways, like sum, or descending, ascending, or multiple fields. And I want to talk about harder things, and that's transactions. In the distributed environment, there are no transactions. Something like distributed transactions, they were dead before they were created already. So we can't make transaction in the distributed way, but we have to. So this is way how you can do it. We call it external identifiers, and that's something. Look if it's provided there. Yeah. The thing is that we have to, when you have one system and you want to write all the data to another system, and you write and then you create an API call, and you will get error. If the error is like, output timeout or timeout, you never know if it was on the way there or on the response. So you will never know if the item is written there or not. So you will retry it, but you will end up with duplicate invoice. And duplicate invoice can be a trouble. So how to handle it? The thing is that the source systems creates, we call it external identification ID, and he says, in my database, this is row number 5. And he writes it to the target system. And he will receive it, and he will make, no, this is your row number 5, as 5 was. But next time, if it fails, and the next time I repeat the request, and he will receive the data and say, hey, 5, I already have one. Okay, I will override the data. And this way, you can be sure that if the write is confirmed by the remote side, that it's written. But if it's not, there is an error, you can retry it, and you will know that there will be no duplication. But your system has to support the external identity field. Usually the external identity field is separated by 2 parts. It's application name, and it's the ID. For example, in FlexiBee, we call it X, comma, my app, for example, my eShop or something that you created, comma, number of in your database or something you wanted. And that was an external identity field, and you could use it for the requests and it made update in the second attempt. Is it clear why? Okay. This is, if you remember one thing in this presentation, the second one will be this. The first is, of course, that developers are the first, are your friends. Developers of or users of your API are. So, external identity fields are very important. Yeah, multi-operations. One of the things that you have to do is, if you don't have the transactions, is that you support multiple operations. In FlexiBee, you can create a company item and the invoice in one request. You put it together and you send it to the server, and he will either commit everything or roll back everything. It will not be partially committed. So this is how we created the transaction support for the customers on the operations. Sorry. Hard thing is going now. Synchronization. Imagine you have 2 applications like an e-commerce shop and an invoicing. And you have to download all the invoices from the e-shop to the invoicing or to the accounting software. And you have to be sure there is nothing missing. And if somebody deleted something, you also converted it the deletion too. There are many ways how to handle it. The first is by creating add or growing ID. If you have SQL, your ID is always growing. So you can say, I want all the invoices that were created by some date. You will write down the last created add of your invoice, and next time you can call again for this one and for this created add, and you will get all the data. Problem is that this doesn't handle updates, so we will change it, and you will ask for everything that is last updated then. Problem is that you have to be sure that all parts of your systems have synchronized date and time. But if you have SQL inside, it's easy to use. But problem is, this doesn't support deletes. That's the problem. So, in FlexiBee, we created something we called changelog. The thing is that, imagine we have to synchronize 2 systems, and there are 20 endpoints. This means that you have to ask every minute for 20 endpoints. Multiply it by 1,000 customers, and your requests are very high, and they are not doing nothing. They are just there to be sure that the systems are updated. So we created changelog, and if you change anything in your system, we write it down to the database that there was change in table A on the item 2, and it was operation delete or create or update. We also write down all the identifiers, for example, the external identifier, so the customer will know when it's changed. And the user of the API can ask, what has changed since the last time I asked, and he provided some cursor to the changelog journal. And we were sure that we provided everything in one request. And when FlexiBee is implemented like SQL store procedure, that when you update something, it writes a note and you can vary it. And also we implemented, it's easy with the journal to implement webhooks. Do you know what is webhook? Yeah, webhook is that, you know, that's Hollywood. Don't call us, we call you. You will register an URL, and when something changes in the application, he will let you know. And that's the solution for thousands of systems, because you register all the URLs and you don't have to ask every minute. But because in many times, minute is too long. So this is a good thing. But you have to create all these steps to get there. Yeah. So how to fully synchronize the systems? The thing, there are many ways. One is that you have a database of 1 billion rows. You can't download them at once because they are too much. So you have to download something, and yeah, you can use changelog, but then they have to know everything from the beginning. But that's not good because there are many changes you don't know. You just want the last line changes. So there is usually the initial synchronization and reaction to changes. In FlexiBee, this was implemented that you requested for the first page of the items, and you got version of the system at that time. You stored it, and then you used the since operator, not the paging, but the since operation, and downloaded all the things to the end. And then you asked for everything that has changed from the version of the first page. Yeah, there can be rows that you already fetched, but you can be sure that you get every change, every delete, every update. Yeah, it's like replication, but in the application level. So, it's not easy, and you have to be sure that you are making it correctly, but then you have full synchronization. Usually, the developers are ignoring this, and they just download the whole list every day. So, community. Okay, that was about the API, and let's talk about the community and so on. One of the good things about FlexiBee was the community we created around the APIs. I spent hours and hours explaining to developers how the API works. I wrote something, and then I received a call from the developer, and I spent an hour explaining the concept. And it was very costly. It was for free, of course, because developers are shy. And it was worth it, because a year later, we received information that in-time expeditions started to use FlexiBee in their systems as part. And they didn't ask us anything. They just knew from the beginning, the explanation in the beginning and all the documentation. So be very kind to developers. And we also created an action we called FlexiBee Developers Day. There was a meeting of developers, there were 100 developers, and we asked all the existing projects to explain why they are using the API, what did they achieve. To explain why they should use the API. Because if you create something like this, there are a lot of developers that are thinking they could use your APIs, but if they used and told the customer that are already using it, they will trust it. And for me, I always asked the customers to when they were telling something we were making wrong, what wasn't working in the systems, I always liked it, because if somebody is telling you about how this system is good, you will not know what is the reality. But if you hear the criticism of it, you will know how far it is. If they criticize that it's not working, still not working, and it's a problem, you will know that it's too early. But if they will discuss details and small things, you will know that it's very robust platform and you can use it. So, community is very important, and you have to support it and make something like that. Make them understand your application and why API is important. So, that's part of the presentation. Today, I think the world has changed. And the thing is that in the past, when you ask somebody, what systems are you using, what software systems, they will tell you Navision or SAP. But today, what will they tell you? We use this CRM, this eShop, this newsletter mailing list, this transactions for mails, this ERP, and you will get to 10, maybe 100 of applications. And this is the thing that has changed, because today we have many applications, and we have to connect them. And the API is the way how to connect them and how to make the applications working together. And the problem is that it's very complex. If you have 10 applications, it means 45 connections. If you have 100 applications, it means 4,500 connections. So it's very good to use some integration platform like Vetiver or Zapier or something like that, that will make it less. You don't have to support all the application because it's easier to connect and use them. And one of the things that I think is more and more important, I call it marketplace. There are some applications that are using it already, and if you are not, you should consider it. Like ShopTet, it's Czech e-commerce platform, and they are doing it very well. Or like AppExchange for Salesforce and many more. The thing is that customers, they have multiple applications and they want them to be connected, but they don't want to develop it. So it's good to create a marketplace where your partners can sell their integrations or their application. In my opinion, it can bring you 20% revenue growth just by providing marketplace. Because there are many partners that are providing software that is connected to yours, and if you provide the platform, the customers will use it. What's important about marketplace? It's not technology, it's marketing. The thing is that if you talk to some partner and you create a connection or add-on, it's important to explain to your customers that they can use it and it's good for them. And the common revenue you can get is 20% just by recommending other software, and that's quite common to get that amount of money just by providing marketplace. So some screenshots. I think that's all from me. So the only thing I want for you to remember: developer is your friend, and you have to work with the developers to persuade them to use your platform, and you have to also support them with your marketing and, for example, marketplace, to help them sell their solution to your customers, and you can get money from that. Okay.
Okay, thank you.